There was a calculation that scientists were told not to do, not because it was hard, not because it was wrong, but because once you did the math, once you really understood what the numbers meant, you couldn't look at the world the same way. Oppenheimer did that calculation anyway. And what he found hiding in the equations wasn't just powerful, it was obscene. The kind of thing that makes you realize nature has been sitting on a loaded gun for billions of years, and we just figured out how to pull the trigger. You want to know what happens when you take the most stable thing in the universe and ask it politely to fall apart? You get energy, not the kind that powers your phone or heats your coffee, the kind that makes the sun look like a candle. And here's what nobody tells you about this energy. Here's the part that made Oppenheimer go quiet when he finally understood it fully. It's everywhere. In your body, right now. In the air you're breathing. In the chair you're sitting on. Every single atom around you is a tiny, compressed universe of power that would obliterate a city block if you knew how to ask it nicely. The mass of 1 penny, if you could convert it completely to energy using the equation Oppenheimer worked with, would power New York City for 2.5 days. 1 penny. Not uranium, not plutonium, just copper. That's the secret Oppenheimer uncovered. And it's the secret that's been keeping physicists up at night ever since. Because if ordinary matter contains that much energy, what does that say about us? What does that say about the fragility of everything we think is solid and safe? And if this kind of stuff blows your mind, hit subscribe, because I'm just getting started. And what's coming next is going to make you see every object around you as a potential bomb that just happens to be really, really stable. For now. So let's talk about what Oppenheimer discovered when he stared into the heart of the atom and found something that shouldn't be possible. An energy source so concentrated, so absolutely ridiculous in its power density, that it makes every other form of energy humans have ever used look like children playing with matches. We're talking about binding energy. Nuclear binding energy. And before you zone out thinking this is some boring textbook physics, let me tell you what binding energy actually means in terms you can feel. It means the universe is held together by the weakest handshake imaginable and also the strongest force ever measured at the same time. It means everything around you is fundamentally unstable, but trapped in a pattern that just happens to work. For now. And Oppenheimer figured out how to break that pattern. He found the crack in reality's armor. And when he did, when he really understood the implications, when he ran the numbers and saw what 1 kilogram of matter could do if you convinced it to give up just a tiny fraction of its binding energy, he realized humanity had just crossed a threshold we could never uncross. We'd found the God code, the universe's source code, and it was written in violence. Now here's where it gets weird. Here's the paradox that's going to make your brain hurt if you really think about it. Matter is made of particles. Protons, neutrons, electrons. Basic stuff. You've known this since middle school. And here's what they taught you. Protons and neutrons cluster together in the nucleus. Electrons orbit around it. Simple. Except here's the problem. Protons are positively charged, and positive charges repel each other violently. Put 2 protons near each other, and they should fly apart like same-pole magnets on steroids. The electromagnetic force pushing them apart is insanely strong. So strong that it should be impossible for atomic nuclei to exist. You can't have a bunch of positively charged particles sitting next to each other. They should explode. Every nucleus should just disintegrate immediately. But they don't. Your body contains trillions of atomic nuclei, and none of them are exploding. Why not? What's holding them together against the electromagnetic force screaming at them to fly apart? The answer is something called the strong nuclear force. And that's where Oppenheimer's discovery gets disturbing. The strong force is stronger than electromagnetism, but only at incredibly tiny distances. We're talking distances smaller than the width of a proton. At that scale, the strong force is about 100 times more powerful than the electromagnetic repulsion. It's like cosmic duct tape. It grabs protons and neutrons and glues them together with a grip that nothing else in nature can match. And here's the insane part. Here's what Oppenheimer understood when he did the math. That grip, that binding force, isn't just holding particles together. It's compressing energy. Massive amounts of energy. When protons and neutrons get stuck together by the strong force, they give up some of their mass. Not a lot, but some. And that mass doesn't just disappear. Einstein showed us what happens to it. E equals mc squared. Energy equals mass times the speed of light squared. That missing mass becomes energy, pure energy. And it's trapped inside the nucleus, compressed into a space smaller than you can imagine, waiting. The strong force is basically a cosmic prison holding more energy than any human technology can match. And Oppenheimer figured out how to crack that prison open. But here's where the paradox really hits. The same force that makes nuclei incredibly stable also makes them incredibly dangerous. Because that stability, that binding energy, it's not evenly distributed. Some elements are barely holding on. Others are locked down so tight they're practically indestructible. Iron sits right in the middle, the most stable element. Uranium sits way out on the edge, heavy and wobbling. And Oppenheimer realized if you could knock uranium off its balance, if you could make it split into lighter elements that are more stable, all that trapped binding energy would come rushing out like water through a broken dam. That's fission. That's the power source Oppenheimer unleashed. And the numbers, oh man, the numbers are absolutely bonkers. 1 kilogram of uranium, 235, if you fission it completely, releases the same energy as 20,000 tons of TNT. 1 kilogram equals 20 million pounds of explosives. That ratio is so extreme it doesn't even make sense. It's like comparing a candle to the surface of the sun. And this energy was sitting there the whole time. In rocks, in the ground, in nature, just waiting for someone smart enough and crazy enough to figure out how to unlock it. Picture this. You're standing in the New Mexico desert. It's dark. The kind of dark that only happens miles from any city. Above you, stars. Billions of them. And each one of those stars is doing the same thing Oppenheimer is about to do, but in reverse. Stars are fusing light elements into heavier ones. Hydrogen into helium, helium into carbon, carbon into oxygen. And every time they fuse atoms together, they release energy because the fused atom is more stable than the separate pieces. That's how stars shine. Fusion. But here's what Oppenheimer realized. Fusion works great for light elements. But once you get past iron, fusion stops releasing energy and starts absorbing it. Heavy elements are on the other side of the stability curve. For heavy elements, splitting releases energy. Fission. So stars create heavy elements in supernovas, but they don't power themselves with them. We do. We figured out how to run the cosmic furnace backward. Now, imagine you could see binding energy. Imagine every atom glowed with a brightness proportional to how much energy is locked inside its nucleus. Hydrogen would be dim, just one proton, nothing fancy. Carbon would glow brighter, 6 protons, 6 neutrons, all that strong force holding them together. Iron would be the brightest of all, the most stable, the most tightly bound. And uranium would be this weird dimmer glow because it's heavy and unstable and wants to fall apart. Now imagine Oppenheimer sitting at a desk in Los Alamos, pencil in hand, running calculations. He's figuring out what happens when you make uranium fall apart on purpose, when you fire a neutron at uranium-235 and split it into smaller pieces. Those pieces, they're more stable than uranium. They're closer to iron on the stability curve. And that difference in binding energy, that gap between where uranium sits and where its fission products sit, that gap is energy, explosive energy. And here's where it gets really wild. When uranium splits, it doesn't just release energy. It releases more neutrons. Those neutrons can hit other uranium atoms. Those atoms split, release more neutrons, hit more atoms, split, release, hit, split, release, hit. It's a chain reaction, exponential growth. 1 becomes 2, becomes 4, becomes 8, becomes 16. In microseconds, you go from one atom splitting to trillions, and all that binding energy comes out at once. Oppenheimer calculated how much uranium you'd need for the chain reaction to sustain itself. The critical mass. For uranium-235, it's about 52 kilograms. A sphere about the size of a softball. That's all you need. 52 kilograms of the right isotope arranged the right way, and boom, you've got a bomb that can level a city. And here's the part that made it real for him, made it visceral. He could hold that calculation in his hands. He could visualize 52 kilograms. It's less than most people weigh. You could carry it. This wasn't some abstract theoretical physics. This was a recipe. And once he wrote it down, once he showed other scientists it was possible, there was no going back. The energy was there. The binding energy. The strong force's grip on matter. And humanity had just learned how to make it let go. And while you're processing that, drop a comment telling me where you're watching from. I'm always curious where in the world people are who want to understand this stuff. Because what I'm about to tell you next is the part that really got under Oppenheimer's skin. The part that made him quote ancient Sanskrit texts and talk about sin and stare off into space like he'd seen something he wished he could unsee. See, the energy itself isn't evil. Energy is just energy. Binding energy, the strong force, the mass deficit in atomic nuclei. It's all just physics, nature doing its thing. But Oppenheimer understood something that most people don't think about. He understood efficiency, and that's where it gets disturbing. Every form of energy humans have ever used before nuclear fission was chemical energy. Burning wood, burning coal, burning gasoline, chemical reactions, and chemical reactions involve electrons rearranging themselves around atoms. The energy released in a chemical reaction comes from electromagnetic forces, electrons finding more stable configurations. And it works. It powers civilization. But here's the thing about chemical energy. It's weak, pathetically weak compared to nuclear energy. When you burn gasoline, you're releasing about 45 million joules per kilogram. Sounds like a lot, right? It's not. When you fission uranium, you're releasing about 80 trillion joules per kilogram. Trillion. With a T. That's almost 2 million times more energy dense. 2 million times. That's the gap between chemical and nuclear. It's not even close. It's not even the same game. Oppenheimer looked at that ratio and realized we'd been playing with toys. Chemical energy is a toy. Nuclear binding energy is the real thing. And that efficiency, that power density, it changes everything. It means you can destroy a city with something that fits in a truck. It means you can power a submarine for months without refueling. It means energy is no longer limited by how much fuel you can carry. And Oppenheimer saw this coming. He saw it in 1942 when he started working on the Manhattan Project. He saw it in 1945 when they tested Trinity. And he definitely saw it on August 6, 1945, when Little Boy detonated over Hiroshima. That bomb contained 64 kilograms of uranium-235. But only about 700 grams of it actually fissioned. Less than 2 pounds. The rest just scattered. And that 700 grams, that tiny amount of matter that actually converted its binding energy into destruction, killed 140,000 people. 700 grams, 140,000 dead. Do the math. That's 200,000 people per kilogram. And we were inefficient. Modern weapons are way more efficient. But even with that primitive design, even with that wasteful use of uranium, the power density was obscene. And Oppenheimer knew it would only get worse. Because here's what he understood about binding energy that most people miss. We were just getting started. Fission was just the first step. The easy step. The real power, the real energy density, comes from fusion. Remember how stars work? They fuse hydrogen into helium and release energy. That's what powers the sun. And the energy density of fusion makes fission look weak. When you fuse deuterium and tritium, two isotopes of hydrogen, you get about 340 trillion joules per kilogram. That's more than 4 times what fission gives you. 4 times. And it's cleaner. No radioactive waste, no plutonium, just helium. Harmless helium. Oppenheimer knew this. He worked on fusion weapons, the hydrogen bomb, Teller's baby. And when those weapons were tested in the 1950s, when Castle Bravo detonated in the Pacific with a yield of 15 megatons, when it vaporized an island and contaminated thousands of square miles, Oppenheimer understood we'd crossed another line. We'd gone from unlocking fission's binding energy to unlocking fusions, from breaking atoms apart to smashing them together. And there was no theoretical upper limit. You could make a fusion bomb as big as you wanted. 10 megatons. 50 megatons. The Soviets tested Tsar Bomba at 57 megatons in 1961. The shock waves circled the Earth 3 times. 3 times. That's fusion. That's binding energy unleashed at the scale where it stops being a weapon and starts being a geological event. And Oppenheimer saw it coming. He fought against the hydrogen bomb. He said it was too much. He said we didn't need it. But they built it anyway. Because once you know the energy is there, once you've done the calculation and seen the numbers, you can't unknown it. You can't pretend binding energy doesn't exist. And here's the really disturbing part, the part Oppenheimer couldn't shake. Binding energy isn't just in uranium or plutonium or deuterium. It's in everything, every nucleus, every atom. The only difference is stability. Some nuclei want to release their binding energy. Others are happy where they are. But the energy is there. Always. In your body, in the air, in the earth, the mass deficit, the strong force's price for holding quarks together. And we learned how to collect that debt. We learned how to make matter pay up. Oppenheimer once said, in some sort of crude sense which no vulgarity, no humor, no overstatement can quite extinguish, the physicists have known sin, and this is a knowledge which they cannot lose. What did he mean? He meant this. He meant we found the universe's energy reserve and we used it to kill. We took the force that holds stars together and we weaponized it. We looked at the most fundamental glue in reality and we figured out how to dissolve it on command. And once you do that, once you cross that threshold, you can't go back. You know what matter really is. You know it's mostly empty space held together by forces you can break. You know every object around you is a frozen explosion waiting for the right trigger. That's what Oppenheimer discovered. That's what haunted him. And this is happening inside you right now. Every atom in your body, every proton in every nucleus is bound together by the strong force. And that binding comes with a price, a mass deficit, a tiny amount of matter converted to energy and trapped as potential. Your body, right now, contains about 7 billion atoms. Most of those atoms are hydrogen, carbon, nitrogen, oxygen, light elements, stable elements. But even stable elements have binding energy. Even iron, the most stable element, has that mass deficit. If you could somehow convert your entire body's mass to energy, if you could break every atomic bond and release all the binding energy at once, you would release about 600 megatons of energy. 600 megatons. That's more than 10 Tsar Bombas. You are walking around with the energy equivalent of 10 largest nuclear weapons ever built, just locked up in your atomic structure, held together by forces that are really, really good at their job. And here's what got to Oppenheimer. What haunted him? You're not made of solid stuff. You're made of energy temporarily organized into a pattern called you. Every atom in your body is a tiny trapped sun, an absurd amount of power held in balance by the strong force. When Oppenheimer looked at the atom, he didn't see particles. He saw potential, potential to create, potential to destroy. And he realized the line between those two things was way thinner than anyone thought. One neutron. That's all it takes to make uranium split. One particle. The difference between stable matter and explosive energy is one neutron in the right place at the right time. And we learned how to put it there. We learned how to tip the balance. And that knowledge, that capability, it changes what it means to be human. Because we're no longer just biological creatures bumbling around on a rock. We're the species that figured out how to unlock the strong force. We're the ones who learned to make matter confess its energy. And Oppenheimer understood the weight of that. He understood we'd taken fire from the gods, except this fire makes regular fire look like a joke. This fire is the sun's fire, the stars' fire, the binding energy that holds the universe together. And we put it in a bomb. We put it in power plants. We put it in submarines and satellites and medical devices. We domesticated the strongest force in nature. And Oppenheimer was the guy who showed us how. That's why he quoted the Bhagavad Gita after Trinity. Now I am become death, the destroyer of worlds. Because he'd seen what binding energy could do. He'd watched it turn sand into glass and create a light brighter than 1,000 suns. And he knew, he absolutely knew, that humanity would never be the same. We'd found the energy source that powers stars, and we'd learned to use it for war. The strong force, the nuclear binding energy, the mass deficit in atomic nuclei, it's the most powerful energy density in the known universe. Nothing else comes close. Not chemical, not gravitational, not electromagnetic. Nuclear binding energy is the heavyweight champion of power per kilogram. And Oppenheimer opened that door. He did the forbidden calculation. He ran the numbers. And he showed us what was possible. And every physicist since then has had to live with that knowledge. They teach it in universities now. Binding energy. Mass deficit. E equals mc squared. But they don't always teach the implications. They don't always explain what it means to live in a world where matter is just organized energy, and we know how to disorganize it. That's what Oppenheimer discovered. That's what scared him. That's what should scare us. So next time you hold anything in your hands, a cup, a phone, a rock, remember what it actually is. It's not solid. It's energy. Bound energy. Mass that gave up a tiny fraction of itself to the strong force and became potential. And inside that potential is enough power to make you rethink everything you thought you knew about reality. Oppenheimer saw this. He calculated it. He built it, and he spent the rest of his life trying to warn us about it. He lost his security clearance in 1954 in hearings that were basically a witch hunt. His communist associations, his moral objections to the hydrogen bomb, his refusal to stay quiet about the dangers. They punished him for having a conscience, for seeing what binding energy really meant and daring to say, maybe we shouldn't just keep building bigger bombs. But the energy doesn't care about politics. The strong force doesn't care about morality. Nuclear binding energy just is. It exists. It's a fundamental property of matter. And now that we know it's there, now that we've learned to tap it, we can't unknown it. We can't go back to chemical energy and pretend uranium is just another rock. The door is open. The calculation is done. The energy is unlocked. And we have to live with that. We have to figure out how to exist as a species that has access to the universe's most concentrated power source. Oppenheimer tried to guide us. He advocated for international control of nuclear weapons. He pushed for arms limitations. He warned against the hydrogen bomb. But the energy was too powerful. The strategic advantages too obvious. And so we built more bombs, thousands of them, enough to destroy civilization several times over. All powered by binding energy, all using the same physics Oppenheimer calculated in the 1940s. The strong force holding nuclei together, the mass deficit waiting to be released. The chain reaction waiting to be triggered. That's the legacy of Oppenheimer's discovery. Not just the physics, the burden, the knowledge that we live on a planet covered in frozen explosions we call matter, and we figured out how to make them explode. Every nuclear power plant is a controlled burn of binding energy. Every nuclear weapon is an uncontrolled one. Same energy, same physics, different intent. And the energy doesn't judge. It just does what the equations say it should do. When you split uranium, binding energy comes out. When you fuse hydrogen, binding energy comes out. Math doesn't care why you're doing it. Nature doesn't have an opinion. But we should, because we're the ones who have to live with the consequences of unlocking this energy. And Oppenheimer understood that better than almost anyone. He saw the bomb work at Trinity. He saw it used at Hiroshima and Nagasaki. He saw the arms race begin. He saw humanity gain the power to destroy itself. And he tried to pump the brakes. But you can't put energy back in the bottle once it's out. You can't make scientists forget what they've learned. The binding energy is there. The calculations work. The weapons exist. And we have to figure out how to not destroy ourselves with knowledge that was literally written into the fabric of the universe. That's what Oppenheimer gave us. Not just a bomb, not just a power source, a mirror, a way to see what we're really made of. Energy, compressed, bound, waiting. And the question isn't whether that energy exists. It does. The question is what we do with it. Do we use it to power cities or destroy them? Do we use it to explore space or wage war? Do we recognize the responsibility that comes with this knowledge, or do we just keep building bigger weapons because we can? Oppenheimer chose his path. He built the bomb because he thought it was necessary to end World War II. Then he spent the rest of his life questioning that choice, wrestling with the morality of unleashing binding energy on human populations, trying to find redemption in arms control and education, and warnings about what we'd created, and he died in 1967, never fully at peace with what he'd done, never able to unsee what he'd seen in that New Mexico desert when the first nuclear device detonated and proved that the calculations were right. That binding energy was real. That matter could be convinced to surrender its hidden power. That humans could touch the strong force and survive. Barely. What would you do if you could see what Oppenheimer saw? If you understood, really understood, that every object around you contains energy that makes gasoline look like a bad joke? If you knew that the only thing keeping your body from exploding is the fact that the strong force is really good at its job, and breaking those bonds requires very specific conditions we've learned to create, would you see the world differently? Would you treat matter with more respect? Would you understand why Oppenheimer looked so haunted in his later photographs, why his eyes held that weight, why he could never quite shake the knowledge of what he'd helped create? Drop a like if this video changed how you see reality, if the idea of binding energy being everywhere makes you rethink what solid actually means. And if you want to keep going down this rabbit hole, hit subscribe and the bell, because there's new revelations every week about the physics that's happening inside you right now, the forces you don't see, the energy you don't feel. But that's there, always, waiting in every atom. Comment which Oppenheimer discovery you want me to explore next. The neutron star calculations he did with Volkoff, the electron-positron pairs, the quantum mechanics that made him famous before the bomb? Let me know. Thanks for watching.